Knowing what SQL statements were running at a specific point in time can be crucial to quick problem determination. IBM Data Server Manager can help. One solution is to use IBM Data Server Manager to monitor the DB2 package cache. The package cache is used to store statements that are frequently used. Data Server Manager reads the top statements in the package cache every few minutes and creates a history that you can use to look back in time. However, since the package cache has a limited size, less frequently used statements are automatically removed from the package cache to make room for the most frequently executed statements. So you cannot rely on the package cache to have a complete picture of everything that's been happening. While the package cache history can often be enough to diagnose problems, sometimes you need a complete history of all the statements that ran on your database, exactly when they ran and how they ran. Or you may need a complete history to support auditing or to charge back usage to your customers. For a complete picture, you need to capture information for each statement as it ran. Event monitoring can create a record in your database each time a statement runs. Before you start to collect the history for individual statements, you should understand how Data Server Manager and DB2 collects event data. Statement history is very powerful, but knowing how it works will ensure that it doesn't use more space or resources than necessary or impact the performance of the database you're monitoring. DB2 Workload Management works together with DB2 Event Monitoring to collect the details behind each statement you want to monitor. When you create a DB2 workload definition, you have the option to also collect detailed information for each statement. These records are recorded in the monitor database in the Activity Event Monitor tables. At regular intervals, Data Server Manager collects the data stored in the Activity Event Monitor tables and writes the record to the Data Server Manager Historical Database repository. The Data Server Manager user interface lets you navigate the data in the historical repository without impacting the monitor database. However, don't be surprised if you don't see the record for a recent statement in the Data Server Manager views right away. Remember, the statements are only collected every few minutes, so it might take that long to see a recent statement. More importantly, after Data Server Manager collects the data from the monitor database, it cleans out the old records by truncating the Activity Event Monitor table. This ensures that a large number of records never accumulate in the monitor database, using up valuable storage. Let's look at a possible scenario. Using Data Server Manager, you noticed a change in the overall time spent. SQL execution time is up along with database CPU time. This abnormal spike seems to happen periodically. After looking at the statement history in the package cache during that time, nothing was obvious. Maybe the statements causing the spike don't run often enough or long enough to be caught in the package cache. To dig deeper, you can enable history collection for individual statements. To use full statement history, select Monitor, then Database. Switch to History mode and click on Statements Individual Executions. If you have not used individual statement history before, you will be prompted to enable the Query History feature in Monitor Profiles. Ensure repository persistence is set on. Expand SQL statement execution data and click Individual Statement Data. Optionally, you can configure the settings for collecting individual statement data. Click on ATS to disable event monitors in failure cases to enable the watchdog. If Data Server Manager stops or can no longer reach the monitor database, ATS will eventually disable the event monitors. You can set how many statements to collect every few minutes and how many to keep in the DSM repository. The default values are set low. For this example, we will set both to 10,000, but you can collect many more statements as long as you have room in the DSM repository. Click Capture in Progress Query with Event Monitor to capture some running queries as well as those that have executed. Analyzing these running queries can help you identify what was happening before a crash occurred. Click Normalize Captured SQL Statements if you want to capture separate records for statements that include parameters. By default, text for statements that differ only in the values of constants embedded in the text are normalized to consolidate them and save space in the historical repository and avoid collecting sensitive customer data. Switch back to Individual Execution page. DSM will display the next steps you need to follow. Each step provides you with a sample script that you can use to set up the storage for the event monitor tables on the monitor database, set up the ATS system, and enable monitoring for workloads. For example, this script creates a buffer pool, a storage partition group, and a table space, as well as a required temporary table space. You can customize the initial and maximum size of the table space in the script before you run it. However, the default sizes should be sufficient for most monitoring requirements. Once you have created the storage space on the monitor database server, you need to make sure that DSM knows where to find it. Select the table space you created earlier from the list of available table spaces in the monitor database. Data Server Manager will use the space to store the event monitor tables. The last step is to configure the workloads in your database for event monitoring collections. By default, there are 2 workloads in every DB2 system, one for user work and one for administrative work. To capture event monitor information, you have to alter those default workloads by adding the Collect Activity Data for All with Details clause to the workloads. We also recommend that you create a new workload to avoid capturing information on the statements that DSM itself runs to collect monitoring data. That makes sure that you only collect information on the statements doing your work in the database. Changes to the workload definition take effect with the next statement that runs. Once you have individual statement history collection running, you can capture all the detail you need to diagnose the transient spike in work. The next time you see the spike, open the individual statement history page and select the time period you want to focus on using the time slider. You should see a history of all the statements that ran during that time window. You will be able to see a complete picture of which statements and which users are driving the work on your database. You can group statements in many ways to see where the work is coming from, and you can sort them to see which group is generating the most work. The queries from IP 9, 115, 4228 seem to spend most of the CPU time during the spike. Now that you know what is driving the work, you can try to reschedule those jobs or see if there are opportunities to tune the statements. You can select a single statement to tune, or you can select multiple statements and tune them as a combined workload. While it takes a few minutes to set up individual statement history collection with Data Server Manager, the power and flexibility it provides can help you diagnose the hardest problems and help you zero in on the exact statements, applications, or users that are generating most of the work in your database.